Assalamu alaikum. Yes, let's discuss about the next concept of our medicinal chemistry part 3. Here we will discuss about bioisosterism and optical and geometrical isomerism. Okay, in previous classes we have discussed till chelation. If you are new to this video, means first go and observe that chelation, solubility, partition coefficient, hydrogen bonding, very important concept those all are. Okay, if you have clear those concepts, means inshallah here there is no doubt for you where in this optical or bioisosterism. Clear? So now what is the importance of this bioisosterism in your question papers? See, in your question papers these bioisosterism asked many times. See, explain the importance of optical and geometrical isomerism in relation to biological action of drugs. Okay, this question was asked in the year 2020. Now again the same question, it is repeated in 2 marks. What do you mean by bioisosterism and give example? Okay, this way they will ask in one question paper every year. Okay, either in 2 marks or in 5 marks, a fixed question here. Now what's the role to study this bioisosterism? My dear brothers and sisters, a very important concept this bioisosterism is. Before going to this bioisosterism, you understand this concept. See, what is bio? Bio means life, iso means same. Means here what happens, the drug or the molecule, they having the same structure, same valency, same chemical formula, and also same biological action or the same effect, same drug use. Simple. This is known as bioisosterism. Now see, for an example, you take nitrogen, N2. N2 valency of this nitrogen is, or electronic configuration of nitrogen is 3. Okay. Here one lone pair, 3 electronic configuration, valency is 3, here 3 into 2, 6, total valency 6 of nitrogen here. Then carbon monoxide, what is the valency here? See, carbon 4 valency plus what is the valency of oxygen? 2, 4 plus 2, 6 valency. See, both having the same outermost electron 6. So this is the beautiful example for bioisosterism. Now let's discuss notes here. See, the condition in which certain drugs and chemical substances or functional group having the same physical or chemical properties and produces similar biological properties, these are known as bioisoters, and relationship between these is known as bioisosterism. And the concept of bioisosterism comes from the isoterism and isosters. Clear? You go through this. These are very simple, very simple. See, main important concept I have explained you that about the nitrogen. Clear? And you don't worry about the notes. I will add these notes in the description. Go and download that. And bioisoterism play a vital role where in the drug design. In order to increase the required biological or physical property of the drug without changing its chemical structure, bioisoterism is required. Means without any changing in the chemical structure, physical structure, what we are doing, we are increasing the biological action, we are increasing the particular action of that drug with the help of this which term, bioisoterism. It is very important here. Then these bioisoters are classified as classical bioisoters and non-classical. See, classical, here the chemical substituents with the same physical, chemical and biological properties like HF. See, you know here hydrogen and fluorine having both valency 1. Okay, so they their properties, physical, chemical or uses, both are same here. Then classification, again this classical bioisoters again classified as univalent, bivalent, trivalent. Simple. Univalent means having the valency 1, hydrogen and fluorine. Bivalent means 2 valency, CH2 and NH. How this? See, carbon. Understand this concept. See, what is this? Carbon. Carbon having 4 valency, 1, 2, 3, 4. Now hydrogen, 2 hydrogen acquired by this carbon. One is H, another one. How many remaining? 2 valency. See, this is bivalent. Now NH. N, what is the valency of that N? 1, 2, 3, H. Okay, 1 nitrogen valency is accepted or is gained by this hydrogen. Remaining 2, what is the valency? 2 valency. Having same valency here, having same chemical structure. So then trivalent same, CH double bond, N double bond. Here if we attach 3 means CH double bond, N double bond. Clear? CH having the valency of 3, here also 3 valence, so it is known as a trivalent. Now this one ring equivalent, same. If you substitute S sulfur to N, then the action of both the drugs are same. Now non-classical bioesters, see here, the concept of non-classical is they don't follow the steric here and electronic rules of the classical bioesters. So they are not similar, but they having the similar biological properties. They are not sharing the physical, chemical or structural properties, but they are having the similar biological properties. This is one of the very important concept here in non-classical bioesters. See, this one is benzene, this one is a naphthalene. They are having different structure, but both are having same uses. See, application, it helps to reduce the toxicity, increase or decrease the bioavailability. It helps to alter the metabolism of heavy metals. Okay, then it improves the potency of the drug. To improve the potency of the drug, we are using this type of the terms like bioisosterism. Now our next concept, the last concept here, optical isomerism. Okay, after that we will discuss in next class a very important concept, that is don't miss that class, about the drug metabolism. Very important one. How inside your body. Now see, the wastage of drug should be excreted either by urine. Clear? That concept is very important here. So now optical isomerism. See, this optical isomerism, the optical isomerism and geometrical isomerism, these will repeat where in your pharmaceutical organic chemistry 3. You don't worry, there also we will go in detail. Now here in optical isomerism you studied where? Optical, where? In the PP2, physical pharmaceutics. See what happens here in optical isomerism. Very simple concept here. When you pass a light, plain polarized light, okay, plain polarized light. See, what is this? This is a lactic acid, COH, OH, HCS3, lactic acid. When the light is passed through this lactic acid, okay, what happens? This lactic acid shows active. Means these, what structure you are observing, no, lactic acid, the H will interconvert to OH here, and OH interconvert to H. Suddenly these compounds get activated. So this activation is known as optical isomerism. Those molecules which have same molecular structural formula and also have same properties but differ in their behavior towards light, okay, having the same structure, but when we pass a light through those material, those substances, suddenly they change their behavior. I will explain you in the next step, you don't worry. Those molecules which rotate plane polarized light, PPL, is known as optical active compounds. See these examples, just convert lactic acid. OH comes here, where? Here, see. Then you know that enantiomers and diastereoisomers, these are mirror images. They form the mirror images. Which one? These enantiomers, these are non superimposable but they form mirror images. But here diastereoisomers, they are non superimposable, but here directly opposite to enantiomers. Why? Means they are non-mirror images. They won't form any mirror type of the compounds like enantiomers. Now drug substances rotate clockwise or anti-clockwise. If they rotate clockwise direction, they are known as dextrorotatory. Anti-clockwise direction, they are known as levorotatory. Now sir, you are telling this much in this video. Now, what is the importance of that? About this optical isomerism? Why we want to study in this medicinal chemistry? See, optical isomerism, one of the very important concept. From my side, I will give 100 out of 95% to this optical isomerism, because a small mistake in this optical isomerism can take a death of the patient. Very important, this one, very minute, but it looks like a very simple, but the role of this optical isomerism in the pharmacy, in the drug here is very sensitive here. See, you know that very well. Dextrorotatory means plus sign, levorotatory means minus sign. Now let's discuss about what the role in the biological action. Here very simple role, various examples are there. Both the enantiomers have different biological activities like dextrorotatory and levorotatory. You know, if they rotate clockwise means dextra, anti-clockwise means levo. Now see here, which one? Levorotatory adrenaline is more active than the dextrorotatory adrenaline. See, levorotatory adrenaline, these are more active compound than the dextrorotatory. In some cases, what happens? One enantiomers is active while the other element isomers is toxic. Now I will explain you in detail. Very simple. See my dear brothers and sisters, what is this? This one is the drug, okay, dextra isomer. Now this one is the receptor. Now what happens? These drug and receptor, they form a good compact of the complex. they can join together. But here what happens, where in this dextra rotatory, if the compound is dextra, if it rotates in a dextra rotatory compounds, means this type clockwise direction, then only what happens, the compound is stable, we can use that. Now in inactive form, levorotatory, anti-clockwise, what happens, see, you are observing the structure, drug receptor. If you pass the plane polarized light, means the structure get inverted and it cannot fix into this receptor. If it can't fix into the receptor, means automatically what happens, the drug action decreases. Drug action decreases means no biological action, no biological role. Simple, very simple concept. See, this only here explained, that is a dextrapenicillamine, then levopenicillamine, inactive. If the compound is dextrarotatory penicillamine, that is a D-penicillamine, then it is active. If levopenicillamine, it is inactive. Now see your application, what is the side effect of that? See here, dextrapenicillamine is used in the treatment of arthritis, while levopenicillamine is a toxic. See, very minute difference here. If you use dextrarotatory, means it is used to treatment arthritis, but if you use levorotatory type of the penicillamine, it's very toxic. This occurs due to the change in the structure of the drug, so it cannot bind with the receptors. Just only I have explained you. Our last concept of today's lecture, that is of geometrical isomerism. See, geometrical isomerism, it is also a stereochemistry. It is also known as a cis-trans isomerism. Here those molecules which have same number, types of atom, bonds, but different spatial arrangement, means that they are different in the spatial arrangement, means structural arrangement different of the atoms. Okay, now what is that spatial arrangement? See, cis form and trans form, you are very familiar this cis and trans from your second PUC. See, C double bond C, CS3 HH, cis it is having same on the upper side, same on the lower side, but here different on the upper side, different on the lower side atoms. That's known as a trans. Now what is the role here? Very important one. It plays a vital role in therapeutic activity of the drug. Cis drug has an anti-cancer, but a trans drug, no, it is inactive towards cancer. See, cis, if you use the cis, means it is an anti-cancer activity, but if you use this transplactin, okay, cisplatin, it is anti-cancer drug. But if you use a transplatin, transplatin means it is not anti-cancer drug. No, it won't shows any properties of the anti-cancer. Yes, my dear brothers and sisters, these are very, very important concepts for your examination. So next we will discuss about the drug metabolism. Thank you. Assalamu alaikum.